Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video. By the end of it, you should be able to solve equations like this. It turns out that we're going to use quadratics to solve these kind of exponential equations. How awesome is that? Quadratics meets exponentials. So you're probably looking at this and thinking, wow, this is not a quadratic at all. A quadratic has an x squared. Here, the x is in the unknown. How are we going to make this into a quadratic? Well, firstly, let's make these two, 9 to the power of x and 3 to the power of x, have the same base. So we know 9 is 3 to the power of 2. So 9 to the power of x is 3 squared to the power of x. Of course, remember when you raise the power to a power, you just multiply the powers. Well, we could write that as 3x squared. They're all the same thing. So we can make this into a quadratic. To make it a little easier, what I'm going to do is I'm going to let y equal 3 to the power of x. So this will be 3 to the power of x or y squared. So my equation is going to become y squared minus 28 times y plus 27 equals 0. Now you can see this is a quadratic. Has been a while since we've done quadratics, so remember for these with 1, 2, 3 terms, we're going to factorize. We're going to find two numbers that multiply to this and add to the middle term. So multiply to 27 and add to negative 28. So those numbers are minus 27 and minus 1. So now we use the null factor law. Either the first bracket equals 0 or the second bracket equals 0. But remember, y is 3 to the power of x. So we have 3 to the power of x equals 27 or 3 to the power of x equals 1. And these are really easy to solve. What do you raise 3 to the power of to get 27? Well, the answer is just 3. What do you raise 3 to the power of to get 1? Well, the answer is just 0. If you substitute x equals 3 or x equals 0 into these equations here, you will get a true statement. All right, let's look at one more example. So let's have a go at this question here. Once again, it doesn't look like a quadratic, but we're going to use the trick that we used last time. 49 to the power of x is 7 to the power of x squared. So what I'm going to do is let y equal 7 to the power of x. So then I have 2y squared equals 56 plus 6y. So now let's solve this equation. So remember, to solve quadratic equations, one side needs to be equal to 0. So what I'm going to do is subtract 6y and subtract 56. So all three of these terms have a common factor. So I'll divide by that common factor, which is 2. So now I'm going to factorize just this quadratic part here. Now that it's monic, I just find two numbers that multiply to negative 28 and add to negative 3. So of course those numbers are negative 7 and positive 4. So my solutions here, I get y equals 7 and y equals minus 4. So remember that y was equal to 7 to the power of x. So if y equals 7, I have 7 to the power of x equals 7. So that, of course, means x equals 1. 7 to the power of 1 is equal to 7. But if I have 7 to the power of x equals minus 4, that has no solutions. You can't raise 7 to a power to get a negative. Remember when we were graphing exponentials, if I were to graph y equals 7 to the power of x, its asymptote would be y equals 0. 7 to the power of x cannot equal 0. It cannot be negative. Same with 2 to the power of x, 3 to the power of x, 5 to the power of x. None of them can be negative. None of them can equal 0. So my only solution to this equation is x equals 1. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.